Picture standing on the floor of the Mediterranean Sea, not underwater. On dry, cracked ground, almost 2 kilometers below where the waves should be, surrounded by nothing but blinding white salt to the horizon. This actually happened. Around 6 million years ago, one of the largest seas on Earth dried up and turned into a desert of salt flats kilometers deep. Then, hundreds of thousands of years later, the water came back in one of the most violent floods this planet has ever seen. We are not talking about a small lake or a shallow lagoon. We are talking about the Mediterranean, the same sea that touches Spain, Italy, Greece, Egypt, and the entire coast of North Africa. For a stretch of time near the end of the Miocene epoch, vast portions of that sea were not a sea at all. They were a baking, sunken wasteland of salt, sitting so far below the surrounding land that if you climbed out of the basin you'd be hiking up a slope taller than most mountains. If that sounds impossible, your next question is the right one. How could anyone possibly know this? Nobody was there filming it. The answer is that the dried-up sea left fingerprints, and they're enormous. The first fingerprint is the salt itself. Buried under the floor of the modern Mediterranean, drilling expeditions have found a layer of salt and other minerals so thick it has its own nickname among geologists. They call it a salt giant. We are talking about a deposit estimated at more than 1 million cubic kilometers of evaporite minerals, salt left behind when seawater evaporates. You do not get a deposit that big from a sea that's behaving normally. You get it when a huge body of water evaporates faster than it can be refilled, over and over, dumping its dissolved salt onto the basin floor like sediment at the bottom of a drying puddle. Except the puddle, in this case, was a sea, and the salt piled up in places to well over 1 kilometer thick. The second fingerprint is even harder to argue with: rivers. When sea level drops dramatically, the rivers that flow into that sea suddenly have a much lower base to flow toward. So they cut downward, carving deep canyons into the bedrock, chasing the retreating shoreline, and those buried canyons are still there, hidden under millions of years of later sediment. The Nile is the clearest example. Far below modern Cairo and even further down near Aswan, geologists have mapped an ancient Nile canyon gouged hundreds of meters below today's sea level. The river was cutting down toward a Mediterranean that had dropped out from under it. The Rhone in France did the same thing. So did rivers feeding the basin from the north. These are not small gullies. They are deep gorges that only make sense if the sea they emptied into had fallen catastrophically far. So we have a sea that left behind a salt deposit the size of a small country, and rivers that carved themselves thousands of feet downward chasing a vanished shoreline. Put those two clues together and they point at the same conclusion. The deep basins of the Mediterranean dried out. This event has a name, the Messinian Salinity Crisis, and it ran from roughly 5.9 million years ago to about 5.3 million years ago. Now for the part everyone wants to know. Why did it dry up in the first place? It comes down to a single doorway. Today the Mediterranean connects to the Atlantic Ocean through the Strait of Gibraltar, between Spain and Morocco, only about 14 kilometers wide at its tightest. That little gap is the sea's lifeline. The Mediterranean sits in a hot, dry part of the world, and it loses far more water to evaporation than its rivers can ever replace. The only reason it stays full is that the Atlantic keeps pouring fresh seawater in through Gibraltar. Pinch off that doorway, and the whole sea is living on borrowed time. That is exactly what happened. The African and European tectonic plates were grinding toward each other, slowly squeezing the gateway shut. At the same time, global sea levels were falling. Together, those forces choked off the connection between the Atlantic and the Mediterranean. With the doorway closed, the relentless Mediterranean sun went to work. Water evaporated and was not replaced. The sea level inside the basin began to fall, year after year, and the salt that the water left behind started piling up on the floor. The science here has shifted recently. For a long time, the picture was a single total drying. But a 2024 study published in the journal Nature Reviews Earth and Environment supports a more layered story, a two-phase crisis. In the first phase, lasting roughly 35,000 years, the Mediterranean was not fully cut off from the Atlantic. Salt was building up, but water was still trading in and out to some degree. It was only later that the deep basins really emptied into those kilometer-deep salt flats. So the cleaner way to say it is that vast portions of the Mediterranean dried into salt deserts in stages, rather than the entire sea simply vanishing in one clean stroke. So picture the world at the bottom of the crisis. The deep Mediterranean basins are an empty, sunken landscape almost 2 kilometers below the level of the global ocean. The air down there would have been hot, dense, and brutally dry, like the floor of Death Valley, but on a scale you can barely imagine. Blinding white salt flats stretch for kilometers. Here and there, a few hypersaline lakes might cling to the lowest spots, water saltier than anything alive could survive in. And because the seafloor was now dry land, you could in principle walk from Africa to Europe across it. The barrier that had separated two continents was for a while gone. It would not have been a pleasant walk. We're talking about a furnace at the bottom of the world. But the geography is the point. For hundreds of thousands of years, the Mediterranean basin was not a sea. It was a desert basin, and the continents around it were temporarily joined by a floor of salt. If you're enjoying this trip to the bottom of a sea that isn't there, stick around, because the way the water came back is even stranger than how it left. And then the water came back. Scientists know the Mediterranean refilled because, well, is that full now? What's still the leading idea, rather than settled fact, is how fast and how violently it happened. The leading explanation is something called the Zanclean flood, named after the geological age that follows the crisis. According to a modeling study by Daniel Garcia Castellanos and colleagues, published in the journal Nature in 2009, the refilling may have been one of the most catastrophic floods in the history of the planet. The idea works like this. Over time, the Gibraltar barrier was breached, either eroded down or dropped by the same tectonic shifting that built it. Once Atlantic water found a way through, it started spilling into the empty basin far below, and water flowing into a hole that deep does not trickle politely, it accelerates. As it pours in, it carves and widens the estuary, which lets even more water through, which carves faster still. The model describes a runaway process, where the inflow cuts a deep groove through the Gibraltar threshold, and the Atlantic comes roaring down it into the basin. The numbers from that model are hard to wrap your head around. The flood may have discharged water at a rate thousands of times greater than the Amazon River. Water levels in the basin could have risen by meters per day, and in the most dramatic version of the scenario, the entire Mediterranean refilled in a window measured not in centuries, but in something closer to a few months up to around 2 years. A sea 2 kilometers deep, refilled in less time than it takes to grow a crop. It's important to keep that figure in its proper box. The months to 2 years timing comes from that modeling work, not from a stopwatch. Some researchers think the refilling was more gradual, or happened in more than one pulse, and the megaflood remains the leading explanation rather than a closed case. But the physical evidence for a sudden, violent inflow is real. Near Gibraltar, geologists have mapped an eroded channel hundreds of meters deep cut into the bedrock, the kind of scar you'd expect from an unimaginable volume of water forcing its way through a narrow gap. Step back and look at the whole sequence. A sea the size of the Mediterranean, choked off by a closing gateway and a relentless sun, drawing down until its deep basins became salt flats almost 2 kilometers below the global ocean. A salt giant, more than 1 million cubic kilometers of it, settling onto the floor is proof. Rivers like the Nile carving themselves into the bedrock, chasing a shoreline that had fallen out from under them. Africa and Europe briefly joined by a desert of salt. And then, after